Hi, welcome to this week 2 video. Today, we're going to see more detail about how to manage BIM data, and we're going to unlock the power of BIM for smarter and more efficient projects. We will start with an introduction, and we're going to see, we already talked about this, what is BIM? Uh, BIM stands for Building Information Modeling. Again, I'm repeating this. It is a digital representation of the physical and functional characteristics of the building or infrastructure project. And why is BIM important for architects? There are many reasons why architects should use BIM as a common practice on their projects. First of all, they will have an improved collaboration and communication among the project stakeholders. Uh, BIM will let architects to work closely with engineers, contractors to ensure the efficient project management and reduce the likelihood of errors and rework. You will also have a better data management and analysis. Architects will be managing easily and analyzing the project data, identifying and resolving the issues to make informed decisions throughout the project lifecycle. Another important thing will be to increase the project efficiency and accuracy. BIM facilitates the creation of a detailed and accurate model. So this can be used to optimize the design and the construction process, resulting on reduced costs and improved quality. Another important thing will be to improve sustainability and energy efficiency. BIM enables architects to assess and optimize the environmental performance of the buildings, helping to reduce their carbon footprint and energy consumption. And well, finally, we can see that with a BIM model uh, can enable architects to create realistic 3Ds so they can visualize, simulate, and help clients and stakeholders understand better the project. And to see all these important things and to analyze all this information, we need to organize the information. So now we're going to see how we can use BIM and manage the data inside BIM. First of all, what is BIM data management? It's a process of collecting, organizing, and maintaining all the data related to the building project in a structured way and also following standards, ensuring the accuracy and consistency throughout the life cycle. So why is BIM data management critical for architectural projects? As I already mentioned, we're going to have improved collaboration, efficient project delivery, reduced errors, better decision making, and increased client satisfaction. I think the last one is the most important. Since we can meet the client's expectations, we can lead to increased satisfaction and repeat future business with the same clients. So how do we organize the data and how BIM integrates all this data? On this picture, we can see we have on the left certain type of information that will be structured data, and on the right we have the unstructured data. So on the unstructured data, we have different type of photographies, maybe documents or specs of the project, emails of confirmation of clients, meeting notes with different topics to be solved, RFIs, tender documents, and so on. And on the left, we have different types of databases, information of the team members. We have the schedules with a time frame of the project, and we have the bill of quantities that will be the cost of our project. And what BIM does is that integrates this data into two sections, we can say. The first one will be the non-graphical data, all of the information that we're not able to show on a graphical way, maybe numbers or maybe emails, different type of documents that are non-graphical. And we have the graphical data. That will be the 3D objects and all these elements with different parameters and information inside. So that's how we can integrate and organize the BIM data. As you can see, we will have everything in one place. Now we're going to see this example of this company that made, they changed the acronym to Better Information Management. It is their term and their marketing and how they use BIM on all their projects. And you're going to see how they, all the comments and all the benefits that they had implementing BIM and managing the data inside on their projects.
The design and development of flagship engineering and architectural projects requires the dedication of a large group of professionals. At IDOM, we work alongside our clients from the very beginning, using BIM methodology in order to deliver a truly collaborative project. BIM allows us to develop 3D digital models to manage the technologies of the project and the input generated by the various teams whilst reducing time and costs. Real-time visualization of the building information model means everyone is on the same page. Modifications are shared and problems are mitigated, resulting ultimately in a successful project.
IDOM have delivered a very robust and detailed design. Dublin Airport is very constrained. Critical Taxiway project will deliver efficiency, flexibility and safety by providing new taxiway infrastructure. One of the big challenges for this project is getting stakeholder engagement, airside operations, airside safety, ATC and all the various other airlines in the airfield. This allows us to program the works and to produce accurate cost estimates.
It gives people an impression about what we are building. These challenges can be found and settled in the design phase. The main goal of the Light Rail project is to make Copenhagen more green.
We will optimize the project when we go to the execution phase. When we go to construct this, a lot of things that usually will be found in the construction part of the project are found earlier in the design phase.
We have so many people involved in the project, and that's the biggest challenge, to get all these things coordinated.
I think the biggest issue we have is the interfaces. The 3D modeling part of the project is the biggest help that we have in order for us to interface check. If there's something in the ground that needs to be coordinated.
BIM actually changed the way in which we work, which really gives a tangible feel for what we're trying to do here in Metrolink. Dublin's a growing city. Metrolink's main goal is to deliver an integrated public transport system. There are multiple stakeholders in this project, and that's where BIM is very helpful. The life cycle asset that we will end up owning at the end of this will be fully recorded through the BIM process. So it's not just about designing for design's sake, it's about designing for the operational life cycle of the project. We're able to communicate more effectively and efficiently about the changes that we want to have made in the design, a collaborative working relationship we have with it to deliver what we think will be a very, very successful project.
biggest BIM challenge that we are facing is to manage the information in the same way, because we have many different designers who are coming on board with their own expertise, and aligning all of that, it's a big challenge.
While we use BIM to create collaborative design and build processes, we will use digital twins to model how people interact with the built environment.
At IDOM, BIM is much more than building information modeling. It is better information management. We now have the tools and best practices that make us an even more efficient engineering and architectural companion, accompanying the client and engaging stakeholders with technology and commitment that is second to none.
Well, another important step to implement BIM inside your organization will be to train the staff. You have to provide training to your employees and team members on managing the BIM data, ensuring that everyone understands the project requirements and BIM standards. And also, as a BIM manager, you have to create a BIM model management plan. This will outline how to review, how to manage, how to update the BIM model throughout the project's lifecycle. On this picture, we can see how we can organize the information and the different requirements. We have two sides, outside the project delivery information and during the project delivery. And also on the other axis, we have high-level information requirements and detailed information requirements. So outside the project delivery and a high-level information requirement will be the organizational information requirements. This include all the team members, what is it that the project is going to be created, and other data on the project. And well, a high-level information requirement during the project delivery will be the project information requirements. This represents when you make a contract, what will be the deliverable of your BIM model, for example. So what will be the detail on how you're going to complete the project. And well, we also have the detailed information requirements that are outside the project delivery, that it's the asset information requirement. This involves all the specs of different equipment, information of the elements that are going to be included on the BIM model. And well, a detailed information requirement during the project delivery will be the exchange information requirements. So this includes what will be the format of the file, what will be the software that we're going to use, and how you're going to exchange the information. You have to consider what parameters are going to be included for exchange the information with the different team members, and also who is going to be responsible for exchanging the information on certain type of detail and speciality. Well, here we can see more detail on how we can organize our BIM data. As you can see, this is part of the BIM execution plan. All these steps that we follow will be part of the BIM execution plan. So that is one step that we have to follow. The first thing we have to do is to identify the BIM goals and uses. We have to define the project team, the value throughout the identification of BIM goals and uses. This means, for example, if we are only going to model for visualization, for rendering, or maybe for construction, we have to define what will be the main use of BIM onto our project. The second step will have to be to design the BIM project execution process. That includes the tasks that the BIM managers, the BIM modelers, and all the stakeholders will have to follow with the information exchanges. Another step will be to develop the information exchanges. This will be the information content, the level of detail of the information, and responsibles of the information, and how we're going to share this type of information. This also includes the format and the software that we're going to be using. And finally, we have to define the supporting infrastructure for the BIM implementation. This needs to be addressed on what will be the computers that we're going to use, how many licenses we're going to acquire for the team, what will be the software that we're going to use also, and what will be the team members that will be using these licenses and this software. So yeah, first of all, we need to have the support of the hardware. We need a good computer to manage the information and all the BIM content. We also need to buy some licenses depending on our budget. And all of these steps needs to be included on the BIM execution plan. Those are mostly the basic steps to follow the BIM implementation process. So we need a document where we specify how are we going to use BIM and how we're going to manage the data. And don't forget also to be aligned to a certain type of standard. A good practice will be to be aligned with the ISO 19650. That is the international standard for BIM management. So that will be something that I would recommend. If you have a national standard that maybe it's aligned with the ISO 19650, you can also apply your standards depending on your location and your needs. Well, now we're going to see the different principles on BIM management, BIM data management. First, we have to know the BIM data types. First of all, we have the geometric data. These will be the spatial and physical properties of building elements. This describes the shape, the size, and location of building components. Also, this includes the information of coordinates, dimensions, and orientation, and facilitates the accurate 3D modeling and visualization of the building design. Second, we have the attribute data. This will be the non-geometric information, such as the material properties, the costs, the manufacturer, among others. This provides additional details about the materials, the performance specs, includes data on cost, energy efficiency, maintenance requirements, and more. This supports decision-making, cost estimation, and life cycle analysis for the building element. We also have the relationship data. This will be the connections and dependencies between the building elements. This represents the functional and structural relationships among the building components. Includes information on load-bearing structures, system connections, and spatial relationships. This type of data enables accurate simulation, analysis, and validation of building performance and constructability. And another data type will be the metadata. This is the data that includes authorship, the versions, the approval status, and this provides contextual information about the BIM data, such as the creation date, the author, the revisions. And with this information, you can keep track of changes of the build model over the time, support collaboration, quality control, and auditing. This helps maintain the data integrity, consistency, and traceability throughout the project lifecycle. On this picture, we can see how we can use BIM 360, Autodesk BIM 360, and we can upload the different versions of this Revit file that it's modified on version 10. We can see the size, the latest update, maybe the responsible, and this will be the metadata information of the BIM data types. That way we can control our project. Another principle of BIM data management will be the data consistency and accuracy. We need to ensure that the BIM data is reliable, up to date, and across all project stages. How do we do that? We have to establish the process and protocols to maintain the data quality, such as regular reviews and validations. We have to check the model. We have to coordinate and synchronize the data updates across multiple project stakeholders and teams, and implement the version control system to track changes and prevent data conflicts. So if we follow those steps and we check the model correctly, we will have a smooth and with no clashes model. That is the main idea of the BIM model, to integrate all the disciplines with no clashes. As you can see on this picture, we have different MEP elements such as pipes and HVAC ducts. And we have to verify that all the systems are not clashing together. And if they are clashing, we have to make the corrections with the stakeholders that needs to address this issue. Another principle will be the data accessibility. We have to provide authorized stakeholders with an easy access to the BIM data. Now with the technology, we're able to use a cloud-based storage and collaboration platform to facilitate the real-time access to the BIM data. Implementing these user-friendly interfaces and visualization tools for the efficient data navigation analysis, we can ensure the compatibility with different software applications and platforms through the use of open data exchange formats. We can have access to the information with our mobile, our tablet, our computer, and assign to the different teams what type of information they can see. This is something we can do with Autodesk BIM 360, which is now part of the Autodesk Construction Cloud. There are different tools such as the one I mentioned, and also from our companies such as Trimble Connect, and more. And finally, and most important, will be the data security. We have to protect the BIM data from unauthorized access and potential breaches. To do that, we need to implement robust access control measures, such as a user authentication and authorization protocols. encrypting sensitive data during the storage and transmission to prevent unauthorized access, and regularly monitor and audit the system activity to detect and respond to potential security threats. Here we can see that data privacy is not equal to data security. Data privacy will be the compliance with data protection laws and regulations, and focus on how to collect, the process, share, and archive the data that you delete, and also the data that you have. Data security are the measures that an organization is taking in order to prevent any third party from unauthorized access. And also the data lifecycle management is important. Managing BIM data from the creation to achieving and disposal. We have to define the policies and procedures for data retention, archiving, and disposal in accordance with legal and industry requirements. Ensure that the BIM data is preserved and accessible throughout the project lifecycle and beyond for future reference and analysis, and regularly review and update the data management policies to reflect the evolving project needs and technological advancements. As you can see, the BIM information, it's in all phases of the project, from the conceptual design to the analysis, documentation, fabrication, construction, operations and maintenance, demolition also, and renovation. It's also worth mentioning the importance of the data exchange formats and protocols. One of the main format used to exchange the different software data and formats will be the IFC format. That comes from the acronym of Industry Foundation Classes. This is an open source format, and it's a format for exchanging BIM data between different software applications. It is designed to enable interoperability among different BIM software tools, regardless of the proprietary formats. Facilitates seamless data exchange and collaboration among project stakeholders, and encourage the development of the open ecosystem for BIM software, promoting innovation and reducing the vendor lock-in. This was developed and maintained by Building Smart International. That is a non-profit organization focused on the development and promotion of open standards for the construction industry. It acts as a governing body for the development and maintenance of the IFC standard, and coordinates with industry stakeholders, software vendors, and experts to ensure continuous improvement and relevance of the IFC standard. The IFC supports both geometric and non-geometric data, as well as relationships between building elements. It provides a comprehensive data model for representing different types of building information, including geometry, the attributes, and relationships. Enables the exchange for not only visual representations, but their underlying data and properties. And facilitates the integration of BIM data with other construction processes, such as scheduling, cost estimation, and facility management. Here we're going to see a video on what is the IFC format and how it can be used.
IFC, or Industry Foundation Classes, is a standard, some would say the primary standard, for open BIM data exchange. IFC is commonly referred to as an exchange format. This is not entirely correct. Firstly, IFC is a schema, not a format, but that's probably a discussion for another time. Let's focus on the exchange part. The current IFC workflow doesn't support data exchange to the extent that I can start modelling in one software, make an IFC export to another application, and continue modelling uninterrupted. It's more accurate to think of IFC as a means of referencing or archiving model content. In the previous video of this series, we presented IFC as the PDF of BIM. Like PDF, an IFC file is a frozen copy of the original content. It can be viewed, measured, used for clash detection, cost estimation or simulation, and innumerable other uses, but should not be edited. A typical IFC workflow could be the following. An architect creates their design model and exports an IFC version to share with, for example, the HVAC engineer. The HVAC engineer can reference this file into their own software and use this for coordination. More than that, the engineer can also use the IFC model as a basis for analysis, example, energy analysis, which is pretty impressive. The IFC transports enough information for the simulation software to read and analyse the spaces in the referenced model. What the engineer can't do, however, is make a change to that reference model. For example, if they want to move a wall or create an opening in that wall for an air duct to pass through. In this case, they must request the change from the architect. The architect, back in their own modelling software, then cuts the opening in their model and issues a new IFC file. It should be said that it is technically possible to edit an IFC model, but that's not the intended workflow. Almost all software that import IFC treat the IFC model as a referenced copy of the original design. Some tools do allow you to make minor edits to an IFC model. For example, splitting a concrete slab element for construction phasing. But this is really an isolated activity and doesn't have any effect on the original design model. The point is that in an IFC-based workflow, each discipline remains author and owner of their model content.
So now we're going to see and talk about the data interoperability and integration with CAM data. There are different challenges for this. First one will be the software formats and data structures. Many BIM and CAM softwares applications use their own proprietary formats and data structures, which can create barriers to seamless data exchange and integration. These formats can limit the ability to collaborate and share data between different software tools and stakeholders. Overcoming this challenge requires the adoption of an open standard such as IFC, or a development of custom data translation tools and plugins to facilitate interoperability. The incomplete or inconsistent data exchange between BIM and CAM applications can be another challenge. Even when using an open standard, the exchange of BIM data with CAM applications can sometimes be incomplete or inconsistent. This is due to different differences in data models and software limitations. You have to be careful because this can result in missing or inaccurate information, and this can affect the overall efficiency and accuracy of the process. Well, how you can address this issue, what you need to do is to collaborate between the software vendors and industry stakeholders to improve data exchange and capabilities to ensure compatibility. Or mostly you have to communicate the different team members the importance of certain type of data that you need to save. Another challenge will be the loss of data, the loss of fidelity during the data exchange. As I already mentioned before, when you transfer data between BIM and CAM, there is a risk of losing the information and lose the data. This can impact on the quality and reliability of the information for the CAM process, leading to potential errors and inefficiencies during the manufacturing and construction. To mitigate this challenge, you need to develop a more robust data exchange mechanism to ensure that the critical information is preserved during the data transfer process. The benefits of BIM and CAM data integration will be the improved communication and collaboration between the design and manufacturing teams. By integrating BIM and CAM data, you can foster a better communication between these two team members, the design team and the manufacturing team. And this will enable to work from a shared and consistent data set. By working together closely, these teams can also identify potential issues to optimize the design, resulting on higher quality outcomes and fewer rework or redesign efforts. As you can see on this picture, we are looking at a rebar set on a concrete structure. So what we can see is that we have the dimensions, the shapes of the rebar that can be made by the manufacturing team. So the design team and the construction team on site will have the exact shapes, and they will save time placing these elements on site. So as you can see, we get more precise results and we don't waste material. Also, if we have a streamlined workflow, we can reduce errors due to consistent and accurate data exchange. When we integrate BIM and CAM data, we can have a more efficient data exchange between the design and manufacturing team, ensuring that everyone is working with the most and up-to-date accurate information. As you can see on this example, we have this detail of this concrete column with all the rebar. And we also have, for the manufacturing team, all the shapes and dimensions that they have to prepare for the construction team. There is also a 3D model where you can see what element will be placed on each place, and different sections, floor plans, and details for the manufacturing team. This is important, so when you have this on the manufacturing, you will save time, and you will also save materials on the construction, and you're going to save hours of work and reduce errors during the construction process. This example has no errors and all the clashes are solved. So this will make a smooth process during the development of the project. And this integration leads to a greater efficiency and cost savings throughout the construction process also, as I already mentioned. We can see on this steel beam connection all the details, all the bolts, and how they're going to be placed, and what are the welding spots, how many plates we're going to use for this connection. And once the manufacturing team has this 3D view of this connection, they will have a clear understanding of the elements they need to fabricate. Adding this to the documents, such as the drawings, they will be able to manufacture a correct shape, and this will be increase the collaboration and communication between the team members. This can also address any issues that we can find. If there's any clashes, we will reduce the likelihood of costly changes or delays during the construction. What we're going to do now, it's an example of how the Autodesk Construction Cloud works. To do this, you need an internet connection and browse on any browser, Autodesk Construction Cloud, and you just need to click into the Autodesk Construction Cloud. And you will require to create an Autodesk account. So what I need to do is to type my account, I type my email, click on next, and now I type my password. Well, this will send me, I need to type a code from my email. So I need to, well, if I have a cell phone, it will send me a code to my cell phone, or maybe to my email. I would use another method since I want the code to get into my email. Click here, use another method, and well, I have my code on another screen, so I will type the code 783112. So that's the way you can get inside and see your projects. Once you're inside the Autodesk Construction Cloud, you have here Home, where you can see all the projects that you have. I don't have any assigned right now, but you will have like a dashboard where you can see what are the issues or any comment assigned to me. You can assign comments to different stakeholders. I have 0 issues, 0 RFIs. You can also generate RFIs. You can also generate submittals, reviews, and meeting action items. You can also do that. Here I can go and I can check my projects. And if I also have a project template, I can create a project template here. On the upper side, I can see that I have the PlanGrid. That it's a platform where you can select different RFIs or any observation from the project. Here we have Building Connected, that it's a platform where you can find different bids or different contractors and projects that are looking for different jobs. TradeApp and Pipe Auto Specs. If I go here, I will see my profile. I don't have a license for this, but I can check my profile here. I want to modify anything from my profile. Well, but what I'm going to do is I'm going to log in onto another account so you can see the projects that I think I have another account with one project, so we can see all the data inside certain type of project. Let me type here. I do have a project inside this. Let's get inside here, and yeah, I do have a project here, and I do have a project here, so we can click inside here And we can see the project here, the project address, the weather, any design issues, so if we have any. And if we click we can check the documents. Here we're on the project home. We can see the documents over here. And we also have insights. So let's check the documents on where we can add all the documents and manage the documents. Let's wait here. And here we're going to see all the folders from the cloud. If we have any reviews, any transmittal, any issues. This is how it's organized. So basically you can add a Word document, PDF documents. I think we have here the BIM models also. Should be here. Let me get inside one BIM model. Yeah, this is separated by different. I think this is the federated BIM model. Let's click here. And well, these are basically the different folders that you can organize your project. You can assign different codes or different names to the folders according to your organization. Let's see if I get this. I'm right now in this big model. As you can see, I also have a BIM execution plan here, a BEP. This is usually a document where I can. This is usually a document where I can save all the elements here. Oh, right now it loads. So what I do have is I have different versions of this file. This is on version 5. And I can see different. If I want to add a description, I can also add a description. The latest update was on January. This is on version 5, and I have 2 files. I have a Navisworks file and I have a Revit file. Inside here, I'm able to upload any file if I want to upload an upgraded file. Or I can get inside a file and analyze. Let's get inside the Navisworks file. So we can see the BIM model of the project. So yeah, what we're looking, it's the whole project here. These dots are basically observations. If I click on here, I will get different issues that somebody had a comment. And if I want to send an email about this issue, I'm able to communicate this. Here's all the detail of the issue, and it's still open. See, this is a warehouse. This is an electrical company warehouse, an office. These are more information about the project, and as you can see, I have everything in one place. So if I want to communicate, what we want to do is to focus on how are we going to communicate the whole project just in one place. That's the main idea of managing this BIM model. So we're going to have all these issues here. And we can see also if we have any sheet or any view. On the 3D view, we will see the 3D element. That this is what we're looking at. And if we save any 2D views, we can also click here. I'm not sure if we have any drawing, but well, the person who developed this file haven't developed the drawings, but you can see also the drawings if you add this into your file. And well, this is basically how the Autodesk Construction Cloud works. You can also make any comments. If I want to comment on any detail here, I can click, and for example, on this corner, I want to do a Vision Cloud. I just type here, and I can click on just this fix. I can add any detail over here. I can make this bigger. Fix this corner. Once I save this, I will have this comment, and I will share this. I'm able to publish this element to anyone. If I click here on publish, I will publish this element. If I want to keep this private, I'm going to work this way. Another benefit of using this cloud collaboration tool, well, this visualization tool, is that you can measure elements. You can click on here. For example, if I want to measure from here to here, I will have the distance. If I'm not happy with the units, I'm able to modify the units here. You have to go to measure and measure settings and go to, let's measure this with meters. And I can modify this into meters. 6.6 meters. I can save this markup and continue. Continue with my project. So as you can see, I have different tools to manage and make drawings and communicate to the team different issues or different details that we want to develop. And this is a faster way of working on any project. Well, and what I want to do now is I want to go outside and I want to show you an example of BIM execution plan. Let's browse. This is on Spanish, but I'm going to show you the examples of the main things that we can have. Well, this is just a format. It doesn't matter the format, but the main thing is, well, here's the general information of the project, the name of the company, then the name of the project, where it's located, and the client also, all the characteristics of the project, the scope. You have to show the scope here, who is responsible on doing what, and all the contacts. Let's go to the next page. And here's where you have to register how you're going to do your workflow. The main objective of the BIM model, you have to put it here. The priorities of the BIM model, this is mostly for coordination. And also, what is the structure of the team? Who's going to manage all the BIM information? What is the software that we're going to use? There will be using Autodesk Revit for the BIM model, for surfaces and ground. It will be AutoCAD with DWG, and with coordination, it will be Navisworks. and also Autodesk Docs or Autodesk Construction Cloud, the BIM 360. Also, how the files are going to be organized. If I want to, this is important here. The strategy of how you're going to organize your models. So on this case, I have the ground or the topography, the architectural model, structures, all the MEP elements, and sanitary separated from here. And all these files will make the master Revit file. So they will be joined together into this file. That is what we're going to use for coordination. And well, that is how this project is organized. Let's go to the next one, and let's see more detail about all the information. Maybe we can see the formats that we're going to use. These are the activities and the standards that they're going to be using. All the formats, RBT file, IFC files, and all the formats that comes with the softwares. And well, the standards, I think they are using the national standard. And now let's see the next page here. This will be some codings from the organization. If you can, this is organized by discipline, how you can organize, for example, general will be gen, or security, safety and security will be SS, and you can assign different codes. This is what is specified on the BIM execution plan. So if you have any doubt of why this code is named this way, you will find this on this document. That is the main purpose of the BIM execution plan. So you will have the data organized and for everyone to understand the workflow. This is more information about the BIM execution plan, and I think this is the activities that they have to follow. Level of security, there is no level of security here, and I think the requirements for safety are aligned with the ISO 19650. Well, this is just an example of how you can manage your information. There are other platforms also. For example, if you don't want to buy a license from Autodesk, maybe you want to manage your information with Procore, that's another option, or you can also try Trimble Connect. Since I do have access to this type of files, I'm showing you this example. So you can see how all of this information is integrated. Well, this will be all for this section. And if we can have a conclusion of this topic, the benefits of BIM data management will be the improved project coordination, reduced costs, management, and the construction also. We can have an enhanced project visualization and analysis. Also easier regulatory compliance and improved project accuracy and efficiency. The best practices for BIM data management will be to educate. Also, we have to train the team. We have to define BIM and explain why it's important for architects. And if you have any questions that you have, please let me know. I will give you feedback. Your questions and comments are welcome. and we'll see you on the next video.